Hey guys, so today we're going to be going over derivatives. So first let's start with how they're expressed. So it's represented as d over d and then the variable that the derivative is taking. So it could be x or y or really anything. Taking the derivative will give you a value that will correspond to the slope of a line at some x value. So basically, it's a more advanced slope, but it doesn't always work. At some x value, it will actually correspond to a slope. Let's take a look at a visual example. Alright, so when we take a look on this graphing calculator, we have a value of fx where fx equals 4. So this is just going to be a straight line. And in the other equation, we're taking the derivative of fx, and it returns 0 because the derivative of a constant is 0. And on this line, the slope is 0 because the line continuously goes straight. The y value never changes. Let's get into the derivative rules. So, as I mentioned earlier, the derivative of a constant is 0, and now the power rule. So the derivative of x to the n is n times x to the n minus 1. And then now the constant multiple rule. The derivative of c times x to the n is c times the derivative of x to the n. Alright, let's practice by finding the derivative. So for the first one here, we need to apply the power rule. So take the exponent down. So 2x, 2 minus 1. And now we just solve for that exponent. So that's 1. So we can write this as 2x to the 1, but that's also just the same thing as just 2x. So yeah, our answer is 2x. Now for the next one, we need to use the constant multiple rule. So 5 times the derivative of 2x, which would just be 5 times 2x, which then is 10x. Derivative of Euler's number, which E. And Euler's number is a constant, so we can just say is 0. Now the derivative of x to 9. So just subtract 1 from the exponent and bring it to the front. So 9x to the 8. And then the derivative of x. This has an interesting solution because there's, of course, an invisible 1 here. So we bring it down, but 1x is literally just the same thing as x on its own. So we don't really need to do that. But then we need to reduce the exponent. 1 minus 1, that gives us x to the 0 power. Which, anything to 0 power is just 1. And surprisingly, we don't just take the derivative of this constant, we just leave it. So our answer is 1.